Data center is the new unit of computing. Cloud computing and AI are driving fundamental changes in the architecture of data centers. Traditionally, enterprise data centers ran monolithic software packages. Virtualization started the trend towards software-defined data centers, allowing applications to move about and letting IT manage from a single pane of glass. With virtualization, the compute, networking, storage, and security functions are emulated in software running on the CPU. Though easier to manage, the added CPU load reduced the data center's capacity to run applications, which is its primary purpose. This illustration shows the added CPU load in the gold-colored part of the stack. Cloud computing re-architected the data centers again, now to provision services for billions of consumers. Monolithic applications were disaggregated into smaller microservices that can take advantage of any idle resource. Equally important, multiple engineering teams can work concurrently using CI/CD methods. Data center networks became swamped by east-west traffic generated by disaggregated microservices. CSPs tackled this with Mellanox's high-speed, low-latency networking. Then deep learning emerged. Magical internet services were rolled out, attracting more customers and better engagement than ever. Deep learning is compute-intensive, which drove adoption of GPUs. Nearly overnight, consumer AI services became the biggest users of GPU supercomputing technologies. Meanwhile, the mountain of infrastructure software continues to grow. Now, adding zero-trust security initiatives makes infrastructure software processing one of the largest workloads in a data center. The applications and services should be. The answer is a new type of chip for data center infrastructure processing, like NVIDIA's BlueField DPU. Let me illustrate this with our own cloud gaming service, GeForce Now, as an example. GeForce Now is NVIDIA's GeForce in the Cloud service. GeForce Now serves 10 million members in 70 countries. 2 years ago, GeForce Now only had just 1 million members. Incredible growth. Gamers are playing concurrently on GeForce Now servers located in data centers hundreds of miles away. GeForce Now is a seriously hard consumer service to deliver. Everything matters. Speed of light, visual quality, frame rate, response, smoothness, startup time, server cost, and most important of all, security. Currently, GeForce Now uses NVIDIA's virtual GPU technology. The virtualization, networking, storage, and security is all done in software. The load is significant. We're transitioning GeForce Now to BlueField. With BlueField, we can isolate the infrastructure from the game instances and offload and accelerate the networking, storage, and security. The GeForce Now infrastructure is costly. With BlueField, we will improve our quality of service and concurrent users at the same time. The ROI of BlueField is excellent. DOCA is our SDK to program BlueField. DOCA simplifies application offload to BlueField's accelerators and programmable engines. Every generation of BlueField will support DOCA from now on. So today's applications and infrastructure will get even faster when the next BlueField arrives. I'm thrilled to announce our first data center infrastructure SDK. DOCA 1.0 is available today. There's all kinds of great technology inside. Deep packet inspection, secure boot, TLS crypto offload, regular expression acceleration, and a very exciting capability, a hardware-based, real-time clock that can be used for synchronous data centers, 5G, and video broadcast. We have great partners working with us to optimize leading platforms on BlueField, infrastructure software providers, edge and CDN providers, cybersecurity solutions, and storage providers. Basically, the world's leading companies in data center infrastructure. We will accelerate it all with BlueField. Though we're just getting started with BlueField-2, today we're announcing BlueField-3, 22 billion transistors, the first 400 gigabit per second networking chip, 16 ARM CPUs to run the entire virtualization software stack, for instance, running VMware ESX. BlueField-3 takes security to a whole new level, fully offloading and accelerating IPsec and TLS cryptography, secret key management, and regular expression processing. Whereas BlueField-2 offload an equivalent of 30 CPU cores. It would take 300 CPU cores to secure, offload, and accelerate the network traffic at 400 gigabits per second, a 10x leap in performance. We're on a pace to introduce a new BlueField generation every 18 months. BlueField-3 will do 400 gigabits per second and be 10x the processing capability of BlueField-2. And BlueField-4 will do 800 gigabits per second and add NVIDIA's AI computing technologies to get another 10x boost. 100x in 3 years. And all of it will be needed. A simple way to think about this is that a third of the roughly 30 million data center servers shipped each year are consumed running the software-defined data center stack. This workload is increasing much faster than Moore's Law. We know this because of the amount of data we're producing and moving around. So unless we offload and accelerate this workload, data centers will have fewer and fewer CPUs to run applications. The time for BlueField has come.